Hi everyone, my name's Ralph Rube. I work with the City of Greater Geelong as a strategic coastal planner. I've worked on the Bellarine Peninsula for just over 30 years, both in marine ecology and coastal planning. So we're here today at the Dell Beach. Along this section of the Bellarine Peninsula, we've got quite a dynamic shallow bank seagrass ecosystem. Historically, this part of the Bellarine Peninsula had broader, wider beaches. Due to shell extraction in the early 1900s, the beaches have narrowed and now really quite vulnerable to coastal erosion. The City of Greater Geelong, as the foreshore manager, is responsible for maintenance of the coast. So we considered a number of options for coastal protection. We could have gone down the path of establishing a sea wall or rock revetment, but instead we opted to construct an artificial reef just offshore. The Dell Reef is a nature-based coastal protection solution aimed at reducing wave energy. It creates a wave shadow between the structure and the coast. The reef also has co-benefits in terms of creating habitat. It provides refuge for small fish as well as crabs. The modules are designed with small hollows and quite a textured surface. This assists marine life in adhering to the structures and colonising each of the modules. The Dell Eco Reef has now been in for 2 years. It was installed in October 2022. We had barges arrive at 7:30 in the morning and the last of the 46 modules went in at 2:30 in the afternoon. The city really looked for an innovative design, so we engaged the Reef Design Lab and its principal Alex Goad to come up with a design that met our criteria but also captured everyone's imagination. As part of planning for the Dell Eco Reef, the City of Greater Geelong thought it best to value add to the whole project. So we partnered with the University of Melbourne and explored different experiments or monitoring programs that they could assist us with.
Hi, my name's Rebecca Morris. I'm from the University of Melbourne and I'm part of the Coastal and Estuarine Adaptation Lab. Today is one project of many that aims to rehabilitate our oyster populations in Port Phillip Bay. The idea is to put 1,000 oysters onto the reef and to track their survival through time. Globally, we've seen an 85% decline in the historical distribution of oyster populations. And with our native flat oyster, less than 1% of its historical distribution in Australia remains. We find them in individual clumps in some areas around the bay, but we don't find them as the reefs that they once were.
Hi, I'm Jack. I'm studying a Masters of Bioscience at the University of Melbourne. We're down here today working on a restoration project for the Angazi oyster. The Angazi oyster is native to Australia. They're functionally extinct at the moment, unfortunately, meaning they don't really have any prevailing habitat left. Previously, oysters used to form really extensive reef habitat all throughout Port Phillip Bay, but unfortunately through a lot of dredging and overfishing, a lot of that hard substrate or habitat that they would live upon was cleared out and replaced with soft sandy sediment.
Today we had a welcome to country, Corinna Eccles, from the traditional owners of the land, the Wadawurrung people. She really highlighted the changes that our environment have gone through. We know that Indigenous people sustainably harvest shellfish for thousands of years, and we know this through looking at shell middens that are found along the coastline.
Midden sites is where the shell, the remnants of the shell of what they were feasting on is built up to create a large mound, and these midden sites are thousands and thousands of years old, and then the top layer isn't that old. It shows our existence and living, but it always shows us what they were living on, what they were feasting on in these areas.
Now, with European colonisation, within 50 years, the shellfish were gone. We lost a key ecosystem within Port Phillip Bay. One aspect that we're focusing a lot on is coastal protection. Commonly, we protect our coasts against erosion and flooding through conventional engineered structures like seawalls and groins. It's being increasingly realised that we can't continue to harden our coasts. It's economically and environmentally costly. The Dell Reef is an example of a nature-based solution to coastal protection. When we look at a natural rocky shore, we see crevices, rock pools, pits, and it's this diversity of microhabitats that then relates to the biodiversity of organisms living on it. These oyster reefs are large, rough surfaces in the environment. They filter water, so they improve water quality. The idea of the Dell Eco Reef is to create these complex habitats, so we see other life around the structure, feeding or sheltering like fish, banjo sharks, rays, lots of different organisms. There's a huge amount of bird life down here at the Dell, and we often see birds sitting on the reef modules and grazing around them.
Prior to today, we ran a pilot study that we've been monitoring for the last 3 months, which we saw promising results in terms of survival and growth within individuals. Two of the biggest issues that this species is currently facing is its lack of substrate for it to actually settle on and grow, which is why this artificial reef is really important for this species. The other really big issue is a real lack of larval supply. By not having reproducing adults out in the ecosystem, we're hoping through this form of direct seeding to help build up some of the adult numbers. It was quite a big job today, putting all the oysters out, but thankfully we had many members from the community come down and give us a hand, and they were really instrumental in our ability to be able to actually put the oysters out on the reef today.
My name is Indigenous Australians. I've been helping the scientists at Melbourne Uni to stick the baby oysters onto the reef modules using epoxy and super glue. I think we put 30 to 40 on each one, all around the module, inside and on the outside as well.
Hi, Rob Gardner. I'm a local who lives in Clifton Springs.
I'm Hans Heine. I retired here and now I work here in the Coast Guard Group as a volunteer. In the Coast Guard Group, we work on the foreshore. We do cleanups, habitat restoration. The Eco Reef is pretty famous now. I think it's an attraction. I think a magnet for locals to gather, and we want to know more about it.
They haven't been in that long, the reef anyway, and it's dramatically different already, the amount of growth. How quickly it gets covered. If you swim around them, fish life inside, and it's amazing.
And I think it should be great, I think, to hear in the future from the research what's coming out, how well they are doing and which one survived and which not. It's quite an interesting habitat here because we have the seagrass there and little birds, little critters, little crabs, all sorts of things. The oysters is probably a new addition to it.
I think probably it's a sort of new old addition because I think oysters here were originally in the millions and now we're bringing them back again, which is great.
Today is experimentally driven to learn more about where our flat oyster likes to live and what might enhance the survival of flat oysters that we put out in the wild so that we can inform future restoration projects.
So after today, we're going to be following up weekly for the first month to check survival of our oysters that we've seeded today. After that, we'll return to monthly. So we're back out here checking the oysters after deployment last week, and they've all attached really well and they're holding on. In 5 to 6 years' time, we'd really love to see natural recruitment coming back onto this reef.
Our aim is to extend the reef with slightly different module designs that will also incorporate the navigation aids. We've really captured the imagination of other coastal managers that could use these techniques in coastal environments that they manage. We hope that the learnings from this project will be able to be used in other parts of the coast, not only in this sort of environment, but could be upscaled for other more open and exposed waters.